Hello my dear students, welcome back to my channel, Essential Academy Chemistry with Vinay. In today's class, we are going to learn about the naming the coordination complex and finding the oxidation state of the central metal atom. So I'll just write it on the what we are going to do today. First one, that is naming of coordination complex, and it is also followed by finding the oxidation state of central metal. So let us start now. Yes. Before going for the naming, that is Iupac naming of coordination complex, finding the oxidation state of the central metal, first let me share a chart with you children. Here is the chart. Here is a beautiful chart. You can just take a screenshot of this. Yes children. In this, I have given one side the name of the ligands. On the other side, I have given the name of the central metal atoms. I have given the name of the ligands on one side, on the other side, the name of the central metal. Let me just tell you the names of the ligands. First, you can observe this side. There is chlorido ligand, bromido, nitrito, hydroxido, cyanido, peroxido, oxido, acetato, cyanato, amido, carbonato, sulfato. All these ligands, they have some charges -1, -1, -1, -1, -1, -1, -2, 2 minus, 2 minus. You should know these ligands with their charges children. These all are anionic ligands. You can also observe here neutral ligands, that is ethane 1,2 diamine, pyridine, H2O, that is aqua, amine NH3, nitrosyl and carbonyl. All these have got a 0 charge. And here there are two more which have got the charge, that is oxalato and nitrato. Remember children, when you are naming the anionic complexes, you should see that they all are named at ends with O. Chlorido, bromido, nitrito, hydroxido, it all ends with O. Oxalato, nitrato. This is all about the different types of ligands, which is very important for your entrance examination. Come to the other side, you can observe here there is a central metal atom. If the given complex is cationic complex, then the central atom name will be this: iron, copper, silver, gold, platinum, chromium, zinc, cobalt, mercury, nickel, manganese. If the given complex is cationic complex. If the given complex is an anionic complex, then the central metal atom will be this: ferrate, cuprate, argentate, aurate, platinate, chromate, zincate, cobaltate, mercurate, nickelate, manganate. You can observe here children, if the given complex is cationic, cat is nothing but cat, no 8. Cat, no 8. The meaning of that, the central metal atom should not be added with, it should not end with ATE. Okay. Then observe this side. If it is a anionic, an I will take it as ant. An I will take it as ant will always ATE. You can observe here, if the anionic complex is given, all ends with ATE, ATE, ATE. Ant 8. Ant is anionic complex. Cat ionic, no 8. That means it does not ends with ATE. If it is a cationic complex, cat, no 8. Ant 8. Anionic, ant 8. Cationic, no 8. So this is a very important chart children. Again and again we'll be using this chart and name the coordination complexes. Let us start some of the examples now. Let us try this example, children. Rule number 1. You need to listen carefully, children. Rule number 1 is to know that whether the given complex is a anionic complex or a cationic complex. How to know that? It's very simple, children. You can observe here the potassium. Potassium has got what? Potassium has got a +1 charge. When this +1 charge becomes the overall charge of the complex, then it becomes what? It becomes Cn, AgCN twice, it becomes -1. Because the charge of the overall complex is minus, therefore it is a anionic complex. It is a anionic complex. How to name this? Rule number 1, recognize whether the given complex is anionic or cationic. This compound is a anionic complex. Rule number 2, always first name the ligands. Naming the ligands first. First, you should name this. Then we should name the central metal atom. Then we should find the oxidation state of the central metal atom. Oxidation state of the central metal atom, that is 3. So remember, first write the name of the ligands. This is a ligand. This is a central metal atom. And find the oxidation state of the central metal atom. And then we can go further. Let us try this example. Rule number 1, first name the ligand. So how many ligands are here? 2. What is the name of this ligand? I'll just show you in the chart how to make use of the chart, children. You can just observe here in this chart. Here Cn has got a -1 charge and it is named as cyanido. It is named as cyanido. So I'll just go back to here. You can observe here. It is going to be dicyanide. Dicyanide. The name of the central metal atom. Because it is an anionic complex. Because it is an anionic complex, I had told you, you have to select the name from this side. So because it is an anionic complex, where is Ag? It is known as argentate. Anionic complex. The name of Ag is what? Argentate. So I'll just write it out. So write down argentate. Open the bracket. Then how to calculate the oxidation state? It's very important. You need to observe, children. Consider the central metal atom as X. Then the charge of one cyanide is -1. The total number of cyanide ligands are 2 into 2. What is the overall charge of the complex? It is -1. Therefore, this is going to be -2, that is equal to -1, or X is equal to 1. The oxidation state of the central metal atom is always represented by a Roman number. First standard. Yes, it is 1. A Roman number 1. And you can observe here, the counter ion given is potassium. Take a space before the ligand name and you just write it as potassium. Let me quickly go for one more example. In the next example, you can observe here, children, there are 2 different types of ligands. Rule number 1, first name the ligands. Rule number 2, name the central metal atom. Rule number 3, write the oxidation state of the central metal atom. Now, when there are 2 different ligands, we call this as a heteroleptic complexes. When there is one type of a ligand, we call it as homoleptic complexes. It is a heteroleptic complexes now. Now, how to name this? It's very simple. This is cyanido, which starts from the alphabetical order C. This is nitrosyl, which starts from the alphabetical order N. Therefore, according to the alphabetical order, C comes first. How many times? 5 times. I will write here pentacyanide pentacyanide and nitrosyl. And what is this known as? It is known as ferret. Open the bracket. Now, how to calculate the oxidation state of the central metal atom? Consider, look at here, children. So sodium has got Na plus. There are two sodiums, therefore Na plus, it becomes 2 plus. When this 2 plus becomes the overall charge of the complex, how much it will be? It will be -2. Yes, now I'll calculate. Consider the central metal atom as X plus the cyanide. One cyanide has got a charge of -1. There are totally 5 cyanides into 5. Then plus nitrosyl has got what charge? You can observe here, it has got no charge in the chart. You can observe here, children, it's a neutral ligand. NO is a neutral ligand. It has got no charge. That is why it is 0. So I'll take it. The charge of nitrosyl is 0. That is equal to overall charge is -2. This overall charge has to be taken after the equal. Then it becomes X minus 5. That is equal to -2. Or X is equal to 5 minus 2, and that is equal to 3. Write 3 in the Roman numbers. So you can observe here the counter ion, whatever is present outside the bracket is a counter ion, and that is sodium. This is all about the naming of an anionic complex. Now let us try the cationic complexes, children. In the cationic complexes, you just see here, I am going to write the charge of the overall complex. For one chloride, it is -1. There are totally 4 chlorides. When this becomes -4, when it becomes the overall charge of the complex, and that will be +4. The overall charge of the complex is plus. That is why it is a cationic complex. I'll just see this one, the other example. The charge of nitrate is -1. When it becomes the overall charge of the complex, it becomes what? It becomes +1. Now how to name this? Rule number 1, always name the ligands first. Then name the central metal atom. Then name the OS of central metal atom, that is oxidation state. Let me do it. So there are 6 times of amine. The name of NH3 is amine. I'll take it as hexaamine. Here you need to be very careful, children, because you need to repeat. You should take twice of M here. Hexaamine. Because it is a cationic complex, I'll take it as platinum. Open the bracket. Now let me calculate the oxidation state of the central metal atom. Oxidation state of the central metal atom. Let me consider the central metal as X plus the charge of NH3. It's a neutral ligand. It has got 0. That is equal to, what is the overall charge of the complex? It is 4. Therefore X is equal to 4. Therefore Roman numbers, it is 4. The counter ion is towards your right side. You just take it as chloride. You write here chloride. Let me try this one. In this example, there are 2 different ligands. It's an example for a heteroleptic complex. What is this En? A very important ligand where you don't take di for this, children. Do listen carefully. You do not take di for this. You will take bis. If there are 2, ethane 1, 2 diamine. If there is 3, you have to take tris. Now you see this starts from E. This ligand starts from the alphabetical order C. Therefore, I'll name this first. Rule number 1, first name the ligands. Rule number 2, then you name the central metal atom. Rule number 3, find the oxidation state of the central metal atom. Yes, it's very easy. Let me go for the ligand. That is dichlorido. This is 2 times. 2 means bis. bis, ethane, 1,2 diamine. Then, what is the name of the central metal atom? I'll write this side, children, so that it will be still easier for you to understand. Dichlorido bis ethane 1,2 diamine. What is the name of the central metal atom? It is chromium. And open the bracket. Now, the central metal atom is considered as what? X. I'll consider central metal atom as X. Then, what is the charge of one chloride ion? It is -1. There are two chloride ions. I'll take it into 2. Plus, the ethane 1,2 diamine is a neutral ligand. It's a 0. That is equal to, what is the overall charge is? +1. This becomes x minus 2 is equal to 1. That is x is equal to 3. Therefore, in Roman number, you write it as 3. Don't you think it's very simple? Yes, it is, children. The only thing you have to take care that if it is a cationic complex, the name of the central metal atom does not ends with ATE. If it is an anionic complex, the name of the central metal atom, it ends with ATE. That's why I said cat no 8. Cat no 8. Whereas ant, it ate something. That's it for in this video. I'll be uploading some more videos of the coordination compounds, children. Do subscribe to my channel for more videos and click on the bell icon. That's it for today. See you again.